Hello everyone, welcome at my session How to Use Your Version Control System as a Goldmine. And to start off, I have a question for you, because probably you have a smartphone, even maybe near you, on your desk or in your pocket. Think about that phone for a moment. What would you do directly after this session, after unlocking your phone with that phone? If you ask that question to me, I would probably say something like, well, reading all the WhatsApp messages that I received from my awesome colleagues about this session. Or I want to relax a bit and play a game. Or maybe I move on working and read my email or even reply on it. What was the thing you were thinking about? When I asked this a while ago to my grandfather, he actually said, well, Jeroen, of course, to call someone. And how could I not think about it? A phone was actually invented to call people. But due to the fact that I know all the other opportunities with it, I prefer to say other things first. What did you do? Well, there is this session going to be about. We are going to look into your repository and find all the possibilities that you can do with the data in your repository. So that you're not only pulling and pushing data to it, but that you also can do a lot of other things with it. But first things first, let me introduce myself. I'm Jeroen Egelmeers, 30 years old, I'm living in Uden. This is in the south of the Netherlands. I'm also working for Society Netherlands as a full stack developer. I've been working for quite a lot of companies, you can see them in your screen below, and I've plenty of hobbies next to my work. But I will say that for now, and let's focus on your repository. Because your repository actually is a gold mine. But how can you get that data out of it, that gold out of it? To firstly introduce you a bit to a repository if you're not known with it, a repository is a data store. We are actually mostly using it for code, to share code over teams or with your team. You can commit and push data towards it, and you can fetch and pull to get it back on your local machine. This way you can share your code with other people and you can work together. Now, how can this actually help you and how can we actually do something with the data? Well, we are actually living in a data-driven world, and you probably know some big companies who really get a lot of money out of the data. Think about Google or Facebook. We also generate a lot of data during our development and our work. But what can we actually do with it? Well, every comment leaves a trace, and every trace is a clue to understand the system we are building. We can mine and measure this valuable information to improve quality. And that is actually the key of this presentation. But how are we going to do that? Well, continuous quality engineering needs tooling. So yes, we are going to use a tool for that. There are plenty of tools on the internet. So it's up to you to find the right tool that will help you find that what you need in your repository. Let me please give you a quick side note. I'm going to use one tool in particularly during this session. You can see it in the center of your screen right now. I will use CodeScene. But there are a lot of other tools. A tool will never be the goal. The tool is a way to reach your goal. So even though I'm using CodeScene, that doesn't mean it will be always the right tool for you. Always investigate which tool is most efficient for your goal. This way you can actually do what you need. Let's give an example for that. See this picture before you. Somewhere in this picture a pickle has been, you can find a pickle. Now it's pretty hard to find a pickle in this image. Can you find it? Try to find it during my presentation while I'm just talking. You can imagine that we can now find a tool on the internet that can focus on that what is most important. Because focus is key. We can look through all data in our repository, but there is a lot of things in our repository that is not that valuable. We need, in this case, the pickle. So all the other information on this picture is not valuable at all. So we should find a tool that can help us find it. So, for example, if you did find it really nice job, else I'm going to help you right now, because I actually found a tool that can help us find that pickle. So I'm asking that tool to remove most of the information. See, there is only a small part of this picture left, and we can actually focus now on that what is most important. And if you look closely to this image, you will see that the pickle is in the center of your screen. You actually found where you were looking for. Adam Thornhill did more research to this on different repositories. He did on 80 months of a repository from 80 months with 400,000 lines of code, 89 software developers, and more than 18,000 changes. Well, while looking through this repository and filtering everything that was necessary out, he was working with only 4% of the code, and that contained 72% of all known defects. Well, let me quickly tell you how he could do this. He had a repository with known defects, and he was actually filtering on only a part of the code. And this way he could find 72 of the defects that were found were in this percent of the code. And that is actually really valuable, because only with this small part of the code you can reach a lot. And I was thinking, how could I help other people in our organization? Well, a lot of things, something that is asked a lot is how to work with technical debt. And in particularly, if you're going to work with technical debt, where should we start? And that question is raised a lot in many projects. Probably if you have been working in some projects, you have heard this question. So where should we start? Here again, focus is key. Because you can do the things right, but you actually should do the right things right. Let's give you an example for this. I was working on a project with a developer that really did like fixing technical debt. And if he was working in a class, he would also refactor it to make it really nice code. And that's really nice. But what if you're working in a class to only fix a small part and you will never touch that code again? Are you then really adding value by refactoring the complete class to fix that technical debt? Or should you just leave it there and maybe leave it what it is and fix other things in the application that you will hit more often? If you're going to work on technical debt, then there are two very important pillars: change frequency and code complexity. And those two things you should take into account when you want to add value to your project. So let's jump into them. First of all, change frequency. On the screen before you, you will see now 3 different repositories. You can find them open source on the internet. And what you can see here are all the files in one model. Each file will get a blue line in this model. And the more changes the file will have over time, the longer the line will be. And what you will see then is that there are some files changed a lot, and it will go with a long tail down the lane with files that are changed almost never. And you see they are almost the same over the 3 repositories. So if you're looking to this model, you should focus on code that matters the most. So that will be on the left side of this model. If you're going down the lane, on the end of this tail, you are touching files that you probably will not hit that often. So fixing code in there will not really add value. If you're changing the left side of the model, you will actually affect a lot of the work from other developers and yourself, and that will really increase your speed and will really make your life better. On the other side, we have code complexity. But how do we measure code complexity? Well, that's really complex. But we are very lucky because a lot of really smart people that think about this. And they came with a few things. First of all, they were thinking about the arrow anti-pattern. You can see it on your screen before you. the further you go into depth, the harder it will be to understand the code. So if you have an if statement, you are checking something. You will have another if statement in there, something else happens. And you can go further and further and further, and you have to take into account all the steps before. Maybe a loop is even a better example. You have a for loop and you go into that for loop. But in that for loop you have another for loop. You have to take into account what happened in the one before, and while I'm discussing this you might already be confused. So, how deeper you go, the more complex it will be. Tools can measure this by the white space before a line. An if statement will start on the front of the line and the next one will have some more white space. So the more white space there is, the complexer your code is. And secondly, you have hotspots. This will be a combination of that code complexity and code change frequency. Together this will become a really rad hotspot on the code scene tool, which I'm using during this session as announced before. So the bigger the circle will be, the more complex the code will be, the more white space will be before your code, and the more red the circle will be, the more changes the file actually had. And this will result in a really nice overview. But still, can you see which files now really have the biggest hotspots and which files we should start working on to fix technical debt? Probably not, because remember, focus is key. So what we should do is zoom into those circles to get more information. And those tools will help you with that. Because for example, in CodeScene you can click on a circle to zoom in and get more information about this particular class or file. So let's do that in the overview we just had. What you can see here is that we zoomed in on one of the files that I did click on. And on the right side of this screen you can actually find some information how to tackle technical debt. You really get an overview how your code looks like, how many commits there are, and much more detailed information. And via this page you can also move on to even more into-depth information. So let's do that. But before I do, I still want to give you once again a side note that I'm using CodeScene during this session, but you really should think for yourself which application is most important for you. Which tool could help you the most to reach your goal? Because once again, a tool is just a way to reach your goal. And I think for this particular session, I could really show you the opportunities with CodeScene. But that doesn't mean it's always the best tool for you. But let's move on. We are going into depth in this file. And I can actually ask the tool to do a review. What should I do to fix a technical debt? You can actually see here, for example, that there are deeply nested logic. So we are going into depth, which we shouldn't do, right? I did just explain it earlier. You are really making the code more complex than is necessary. You should split this up and make it really nice short functions. Do you know clean code? You should look it up if you don't know it and find how you should write clean code and fix those kind of issues. But there are many more. You can see that if you scroll down this page. There are also a lot of other really cool opportunities in those kind of tools. Because if you're working with those kind of tools, you probably know how to do reviews and to get quality checks in your CI/CD pipelines. But did you also know you can actually get organizational data or social data? How is your team working? And where should you be to find the right person who has the knowledge about a particular part of your code? If I'm starting on a new project, this view could be very valuable. Because maybe I want to know who actually has a lot of information about the PHP part of this application. And if I'm looking in this overview, I can see that I should go to Pragmatic Joe. This way you can actually go and find the right people if you have questions. That can really speed up the time that you need to get into that project. Also, if you're working in files and you get stuck somewhere, you know where to find help. You're really adding value, and the information is just available for you. You just need the right tool, just like I explained before. But there is much more, because also for product owners or managers, tools can be very, very nice. Because let's look into this overview, knowledge distribution. Here you can actually see what happens if someone is leaving the project. This way you can act before someone is leaving by, for example, sharing this knowledge over other team members. But this can also help to hire the right person. And you might think, well, if someone is leaving, it's clear who to hire, right? But let's get another example I faced during one of the projects I've been working on. I was working on a project and someone was leaving the team. And his manager was looking his profile up and he saw he was a Java developer. But actually, he was always working on the JavaScript side of the application. And this is completely something different. JavaScript is the front end of the application, a complete different expertise than the back end, which is Java. Now, this manager didn't know and was hiring another Java developer. So the developer left the team, a new Java developer joined the team, but that Java developer didn't have any knowledge about JavaScript. And you can imagine what happened. We had an issue on the front-end side of the application. If that manager did look into this application, into this tool, and he would see that that person was actually working on the front end of the application, he could act on it and hire the right person. Or make sure that someone else was joining that part of the application, if possible, and then still hire a Java developer. But as he didn't know it, didn't act on it, didn't discuss it within the team, he was not able to fix that issue and hired the wrong person. And you can imagine this is bad for everyone. The Java developer who was hired was not happy and the team didn't like it as they had a problem on the front end of the application and their work. So this is really valuable also, for example, for managers, product owners, Scrum Master, you name it. Let's look into another overview. Because next to knowledge distribution, you also have knowledge fragmentation. And here you have actually an overview of everyone who changed that particular file. And here I have two pictures of two different files. I'm asking you, which file do you think that is best? The one on the left side, which has been changed by a lot of people, or the one on the right side, which has changed by almost no one, only a few? Well, let me explain you. First of all, the left side. On the left side, a lot of people changed the file, but I can tell you that's not really a good thing. Because if I'm asking you to write about something, you will do it slightly different or maybe even really different than someone else. Everyone has its own way of writing. Of course, you can discuss guidelines and do other things to raise the quality level and make sure people are on the same line, but still, you will have some slightly different way of working. So if a lot of people are working on the same file, that could make it more complex. On the right side, you have only one person who really has knowledge about this file. That could be a good thing. Let me explain you. For example, if you're pair programming. Because if you're pair programming, you are working with two people on the same computer, on the same file then as well. Only one person who is actually, from who that computer is actually committing the code to the repository. So it's on his or her name. But it was developed by 2 people. Now, that would be a good thing. But let's think about just this example that only one person did commit it. And that way you can look back on the knowledge distribution. If someone is leaving the team, you will have a lot of lost knowledge. And you have to make sure that you will bring this over to other team members. If you don't, you lose it, and it will be harder in the future to change this file. So it should be something in the middle. Or the pair programming example, or you should, for example, have like 2 people who have knowledge about this file. But there is more. Let's look into social networks. Because what I just told is that also product owners, managers, scrum master or other management level people can actually get a lot of value out of the repository. And this is another example. You can actually see how a team is working. Let's get again 2 examples. On the left side you have an example with teams that are mostly working together, and on the right side you have teams that are completely messing up things. And you should work towards the left image. And why is that? Well, a team should be a component on its own. It should work together as a team. It should not have too many things with other teams, because that will probably slow them down. They will need information from other teams, but that will be maybe in another building or another country. They have to call them, get into touch. That will be way harder than with your own team, because probably you have something like a daily scrum and you can discuss it every single day with your own team. On the left side, you can actually see teams that are working together and maybe a bit to other teams. That's fine, because you will always have that in big repositories or organizations. So that is actually a good thing. They should work together, maybe a bit with other teams, but mostly with their own team. Most tools will also give you the option to look into your code health. CodeScene calls this biomarkers. You will see here, for example, if you have brain methods. Methods of a single functional method that centers too much behavior. Nested complexity. Do you remember those if statements every time? Where you have more and more white space, where we measure complexity with. Or dry, don't repeat yourself violations. And many, many more. You can just look them up on the internet, or for example on the CodeScene website. They will explain how this works and where they will be measured on. This will give an overview of how your code actually looks like. Every tool does this on its own way. CodeScene, for example, uses the alphabet, so A, B, C, etc. And if it's going deeper, it will be a worse score. So for example, if you look at the screen, last month we had a D, which is not so good. You can see it in red. Currently we are at a C. We actually evolved. We did a good job there. We made the code better. You can use this, for example, in your retrospectives. You can add something to it and say, let's raise the bar next time and make sure we will move to a better grade. You can also look that over time. You can see how your code is actually evolving. Are you actually doing things better? Are you actually fixing technical debt? Are you doing the right things right? Do you remember? This way you're actually bringing up your quality. You're making better code, and you're actually making sure that you're developing an environment that is better for everyone. So that's it. Focus is key. We started with that big repository with a lot of data. We focused and got to hotspots. we prioritized them and made sure that we zoomed into those hotspots that were most valuable for us to fix. This resulted in, for example, code biomarkers. You get information about how to fix them and how you should actually bring up the quality in your code. And this way we did bring it down to only that part that will make it more valuable for your project. If you're working with those kind of tools, always try to automate it in your CI/CD pipelines. This way you can commit and actually get direct results. Tools can actually inform you already before you are merging to, for example, develop or further. So make sure to implement this. Maybe you're working with work in progress pull requests. This way you actually can start a pull request, ask peers to actually do some reviews already, but also ask the tools to do reviews at each commit you're doing to that pull request. That is a really nice way of working, and you will actually really raise the bar of quality in your project. And I would highly recommend doing that. This way you will get detailed information in your pull request from the tool what you should do to raise the bar. Just like an example you can see now on your screen. So even though I explained in the beginning of this session that you should pick the tool that is best for your project, I can imagine that I picked your interest for CodeScene during this session. So because of that, I'm explaining how you can try it out yourself. You can go to the CodeScene.io website and use your GitHub account to log into the website. This way you can actually use your open source repositories and work with it already. If you want to work with private repositories, then you need the paid plan of CodeScene. But if you just want to test what you can do more with CodeScene than I already explained during this session, you can just use one of the open source repositories that are already configured by CodeScene itself. You can just click through it and do the things I just did during this session and find out all other things available there. But please keep in mind that other tools also have really nice things for you out there to play with and to get even more information out of your repository. Talking about your repository, I hope you are able to discuss with them all other opportunities you can have with your data, so that you're not only can push and pull data from your repository, but also configure awesome teams, tackle technical debt the right way, or know who to hire to make sure you don't lose any knowledge. So all those options you have, just like the phone example I had all in the beginning of this session. Thank you very much for having me, and if you want to know more about me, please visit my LinkedIn page. I hope you have a wonderful day. Thank you.